Welcome to Starry Cosmos, far beyond the bright, crowded shores of our galaxy, past the rivers of light that braid the cosmic web together. There is a place where the universe simply seems to stop. It is called the Boötes Void, a near-perfect sphere of darkness, 330 million light years across. Tonight, we are going to drift out into it, slowly, gently, until every familiar star falls away behind us, and there is nothing left but the soft, endless dark and the quiet sound of your own breathing. So dim your lights, settle in, get yourself comfortable. Let your breathing slow, and let us begin. If these quiet journeys help you drift off, take a slow breath and subscribe to Starry Cosmos so the next one finds you when you need it. Imagine drifting slowly, silently through the night, not just any night, but the night that stretches across billions of years and unthinkable distances, the night that is the universe itself. For most of our lives, we've understood the cosmos as a vast expanse, seemingly limitless. And while that fundamental truth remains, the way galaxies are arranged throughout it has become extraordinarily clear in recent decades. They aren't scattered randomly like dust motes across an endless black canvas. Instead, they gather along enormous, luminous structures known as the cosmic web. Think of it not unlike peering into a dense forest. You don't see individual trees floating alone, but rather a tangled network of branches and trunks interwoven to form something far grander than any single component. And within this intricate web, our own home resides. We find ourselves nestled inside Laniakea, a name meaning immense heaven in Hawaiian, a fitting description for this sprawling supercluster that contains dozens of thousands of galaxies, all gravitationally bound together in a complex dance of cosmic proportions. Light radiates from every corner of Laniakea. The combined glow of countless stars and Nebulae creates a bustling region teeming with energy, a localized pocket of concentrated existence within the wider universe. Consider for just a moment the sheer scale of that. Billions upon billions of stars, each potentially harboring planets, worlds we can only dream about, and all of them contributing to this incredible density of light and matter. It's a vibrant tapestry woven from dark energy and gravity. Now, picture yourself beginning a journey outward, leaving Laniakea behind. There's no sudden departure, no dramatic acceleration. This is a gradual drift, a silent slide through the fabric of space-time. As you continue moving away, something subtle begins to shift, a change so gentle that it might easily go unnoticed if you weren't actively observing. The brilliant filaments of galaxies that defined your surroundings slowly begin to thin out. They were once thick and robust, like rivers full of light. Now they are becoming more wispy, fading at the edges as though diluted into nothingness. The distances between galaxies start increasing, not dramatically at first, but steadily nonetheless. What were relatively close neighbors a moment ago now appear as distant beacons in the darkness, their glow diminishing with every kilometer you traverse. It's like watching a vibrant city recede into the night, its lights gradually fading until they become just another faint star amongst countless others. This is not an illusion. The space itself is expanding, carrying galaxies further apart from one another at an accelerating rate, driven by something we call dark energy, a mysterious force that permeates the universe and dominates its behavior on the largest scales. The constellations you are familiar with, Orion, Ursa Major, the Southern Cross, these familiar patterns begin to lose their definitive shape. They stretch and distort as your perspective changes. You realize, perhaps for the first time, how fragile our human understanding of the cosmos truly is. The maps we create, the names we give to these celestial structures, are all based on a single vantage point from Earth, from within Laniakea. As you move further out, those familiar landmarks dissolve into an ever-changing backdrop. The space between galaxies isn't truly empty, of course. There's still matter present, wisps of gas and dust, dark matter halos stretching far beyond the visible boundaries of galaxies. But the density is drastically reduced compared to the bustling regions within Laniakea. These remnants are like faint echoes of a past existence, vestiges of structures that once thrived in this area, but have since dispersed into the wider universe. Consider what it means to be moving through such vastness. The light you see from distant galaxies has taken billions of years to reach you, a testament to the immense scale of the cosmos and the relentless march of time. Each photon, each tiny particle of energy, represents a journey across unimaginable distances, a snapshot of a galaxy as it existed long ago. As you proceed further outward, these photons become increasingly faint, their signals weakened by the intervening expanse, and then something truly profound begins to emerge. A sense of utter desolation. The luminous filaments, once so clearly defined, start to unravel completely. They break apart into smaller strands, fragmented and diffuse, shimmering faintly against an ever-darkening background. It's a gradual transition. There's no sudden drop into nothingness, but rather a slow fading away, a gentle dissolution of structure. As you approach the frontier of emptiness, ahead lies a region so sparsely populated that it challenges our very understanding of what constitutes space. This is not simply an absence of galaxies, it's an absence of nearly everything, even the faint wisps of gas and dust that linger in other regions. It's a place where the cosmic web, once so vibrant and interconnected, finally gives way to the dark, a vast expanse of true nothingness. This frontier is known as the Boötes Void, an area stretching over a staggering 330 million light years across an area so large that it contains just a handful of galaxies compared to the billions found within Laniakea. It's like traveling from bustling city center into the vast, uninhabited wilderness, an experience both strangely beautiful and deeply unsettling. The silence is absolute, not merely the absence of sound, for space has no medium to transmit sound, but the complete lack of radiation, of light, of any discernible form of energy. The sheer scale of the Boötes Void is difficult for our human minds to truly comprehend. We're creatures evolved in a relatively dense environment, a planet teeming with life and surrounded by the comforting glow of the sun. The idea of traversing such an enormous expanse of near absolute nothingness is fundamentally alien to our experiences. It's an encounter that forces us to confront the true immensity of the universe and our own insignificant place within it. And yet, even in this region of profound emptiness, there remains a certain kind of beauty, the stark simplicity of the blackest darkness imaginable, a canvas upon which the faintest light can shine with extraordinary brilliance. It's a reminder that even in the most desolate corners of the cosmos, something remarkable persists. The unwavering rules of physics, the relentless expansion of space-time, and the quiet dignity of existence itself. As you continue your drift toward this frontier, feel the stillness around you, the utter lack of anything to interrupt the vastness, and consider what it means to be a small observer in an unimaginably large universe. And now, as you approach this boundary, a profound shift occurs. The familiar tapestry of galaxies begins to unravel, their faint flickers diminishing into an almost impossible stillness. It's not merely a reduction in brightness. It's something far deeper, a palpable absence where light itself seems to hesitate before venturing onward. You are entering the realm of the Boötes Void, and the feeling, while quietly awe-inspiring, carries with it a distinct sense of emptiness. This region wasn't always known to us. You see, it was largely invisible until 1981, when astronomer Robert Kirshner, along with his team, stumbled upon an anomaly in the flow of galaxies. as they charted their movements across the sky. They were studying what astronomers call peculiar velocities, those instances where a galaxy is moving in a way that doesn't quite align with the general expansion of the universe. And within this broad investigation, a peculiar lack emerged. Fewer and fewer galaxies appeared along a specific line of sight. It was as if the cosmic scaffolding had simply vanished, leaving only nothing. At first, some scientists considered it an observational bias. Perhaps there were obstacles obscuring their view, or maybe they'd missed crucial data points. But subsequent observations with more powerful telescopes and refined techniques confirmed it. A vast, nearly spherical emptiness stretching across our vision like a cosmic absence. It's difficult to truly grasp the scale of what they had found. You can try to imagine it, but our minds often struggle to comprehend dimensions so far beyond the everyday. Picture this: a sphere with a diameter of approximately 330 million light years. That means if you were somehow able to travel at the speed of light, an impossibility, of course, yet a useful thought exercise. It would take you 330 million years to cross it. And think about what that represents. Each light year is the distance light travels in 1 year, nearly 6 trillion miles. So we're talking about an expanse so immense, existing on a scale almost beyond human reckoning. Now, you might be thinking that empty spaces exist throughout the universe. After all, galaxies aren't neatly arranged like grains of sand on a beach. And you'd be right. Ordinary cosmic voids are commonplace. These are relatively smaller regions where the density of matter is significantly lower than average. They are the natural consequence of gravitational interactions over billions of years, places where dark matter and regular matter have pulled away from each other, leaving behind vast stretches of comparative emptiness. These voids often appear irregular in shape, like bubbles within a foam. But the Boötes Void, it's different. While ordinary voids can be quite large, this one dwarfs almost all of them. It's not just significantly bigger. Its near-perfect sphericity is incredibly unusual. Most known voids are irregularly shaped, influenced by local gravitational forces and the uneven distribution of matter. The Boötes Void seems to have been sculpted into a remarkably smooth sphere, an unsettlingly uniform expanse of nothingness. Consider also what it means to be surrounded by this vast emptiness. Imagine a lone astronaut drifting through the void, not near a planet or moon, but suspended completely within that sphere. Around them, there would be virtually no stars, no galaxies, only the faint, distant glow of matter. lying beyond this cosmic bubble. The silence, you can imagine, would be absolute. No background radiation, no whispers carried on light waves, just an immense, isolating quiet. The question naturally arises, why is it like this? What could have possibly carved out such a colossal region of emptiness? The truth is, we don't fully know the answer yet. Several theories have been proposed, and each offers a tantalizing glimpse into the complex processes that shape our universe. One possibility involves giant superclusters of galaxies, massive collections of galaxy groups bound together by gravity. These superclusters could, over immense timescales, have gravitationally pushed away matter from their centers, creating vast voids in space. Think of it like sculpting with gravitation. These enormous cosmic structures acting as a sort of cosmic chisel, removing material and leaving behind an emptiness. Another compelling, though more speculative, idea involves primordial fluctuations, tiny variations in the density of matter that arose during the very early universe, just fractions of a second after the Big Bang. These fluctuations, amplified by the expansion of space over billions of years, could have seeded the formation of voids like the Boötes Void. Imagine the initial conditions being slightly uneven, some regions having marginally less than average material density. As the universe expanded, these regions would naturally become even emptier, eventually growing into vast voids. And then there's the possibility of something even more exotic, that this void isn't truly empty in the traditional sense, but is instead influenced by something we don't yet understand. Perhaps a previously unknown form of dark energy, or a subtle effect related to the topology of space itself. This idea appeals to those who find the apparent simplicity of the existing theories unsatisfactory. It suggests that the Boötes Void might be hinting at some fundamental aspect of the universe beyond our current understanding. It's worth acknowledging, too, that our observations are always limited by what we can see and measure. We only have a snapshot in time, a single moment within an infinite timeline. What if the Boötes Void wasn't always empty? Perhaps it was once filled with galaxies, which were then stripped away over eons through some cataclysmic event or gradual process. While this is far from confirmed, it highlights how much we still have to learn about these vast structures. As you continue your journey deeper into the void, notice how even the faintest background glow seems to diminish further. It's not that there's nothing there. Rather, it's a matter of degree. There are still sparse galaxies scattered throughout, the remnants of what might have once been a more densely populated region. but they appear diminished, isolated islands in an ocean of darkness. They seem to hang suspended within a deeper stillness, like tiny points of light struggling against the immensity surrounding them. The sheer scale of the Boötes Void is difficult to fully appreciate through numbers alone. It's not simply about light years or diameters. It's about contemplating the possibility that vast regions of space can exist with so little matter, so few galaxies, a testament to the inherent emptiness within our universe. And in this sense, it forces us to reevaluate our own place within the cosmos. We humans, who build cities and launch spacecraft, who trace the arc of civilizations across millennia, we are profoundly small occupants of a system filled with vastness. Perhaps that's what makes the Boötes Void so compelling. Not just its size or emptiness, but the profound sense of perspective it offers. It reminds us of the fragility of existence and the sheer improbability of our own presence within this unimaginably large universe. You might feel a stir of melancholy as you witness this cosmic absence, an acceptance of the fact that space is not filled with everything, that there are regions where stars do not shine, where galaxies do not congregate, where matter exists in strikingly low densities. And yet, paradoxically, this vast emptiness doesn't dim the wonder of the universe. It amplifies it. It highlights the extraordinary conditions required for life to arise. And for us to be able to observe these wonders from our tiny planet, it underlines how improbable it is that we are here at all, witnessing these cosmic landscapes. The Boötes Void is a reminder of both the scale and strangeness of the universe, a place where things can disappear as easily as they appear, a space shaped by forces beyond our full understanding. And yet, even in its emptiness, there's an undeniable beauty, a silent grandeur that speaks to the depths of the cosmos. And so, to truly contemplate the scale of this void, to feel its vastness pressing in upon you, let's consider a rather peculiar notion. Imagine traveling through it at the speed of light. It's a thought experiment that stretches our intuition and reveals just how profound this emptiness really is. Light itself, as you likely know, is the fastest messenger we know of in the universe. Nothing can move quicker. No force known to us can accelerate an object past its ultimate limit. Yet even at this unimaginable speed, traversing the Boötes Void would feel sluggish. Let's define a quantity for ourselves, something that might help convey the sheer distances involved. A light day. A light day is simply the distance light travels in a single day, an astounding 29,976 kilometers. nearly 18,600 miles, and it's traveling at about 300,000 kilometers per second. If you were to close your eyes for just a moment, you would travel further than the Earth's circumference, almost 7 times over. But even that remarkable distance pales in comparison to what lies ahead. Now, picture yourself accelerating, shedding every ounce of inertia, beginning an unrelenting journey through the Boötes Void. At this blazing speed, you're not feeling any force. Relativity dictates that inside a perfectly smooth-moving spacecraft, there is no sensation of motion, no wind, no vibration, nothing to betray your incredible velocity. The vastness outside your window remains unchanged. Starlight streams in, as it always has, beautiful and distant. Initially, you might expect the landscape to pass by with dizzying speed, to see stars blurring into streaks of light, but that expectation quickly dissipates. Within the void, there are not many stars to begin with. It's an astonishing absence, a vast gulf where galaxies are scarce, where entire regions of space exist almost devoid of matter. And because you are traveling at the speed of light, the absolute limit of velocity, the distances between those few scattered points become stretched and distorted in ways that defy everyday experience. Days turn into weeks. Weeks melt into months. You continue your unyielding progress, yet the scenery remains almost unchanged. The emptiness persists. Each passing day adds only a tiny fraction to the total distance you've covered. A light day's worth, of course, but compared to the overall scale of the void, it's barely a flicker on the cosmic canvas. It's as if you were trying to measure the circumference of the Earth with an ant, taking one step at a time. The effort would be monumental, the progress agonizingly slow. This is because the sheer size of the Boötes Void dwarfs everything else we typically consider in astronomy. Its volume, the space it occupies, is estimated to be over 30 billion cubic megaparsecs. That's an almost incomprehensible number, larger than anything you've likely encountered. To put it into perspective, if our own Milky Way galaxy were positioned at the center of this void, all the other galaxies within a radius of nearly 200 million light years would still fit comfortably inside it. And as you travel, something more subtle, yet equally profound, begins to emerge. With no nearby landmarks, motion becomes almost impossible to feel. There's nothing to compare your speed against. No neighboring galaxies drifting by, no clusters of stars shifting in perspective. You are suspended in an environment utterly devoid of reference points. It's like floating aimlessly in the deepest ocean. No currents to indicate direction, no coastline to signal approach. Just a boundless expanse of water stretching infinitely in all directions. The concept of distance itself begins to blur as well. Relativity dictates that time and space are interwoven, and your velocity profoundly affects how you experience both. What might be considered years by someone observing from the outside, a human on Earth, for instance, could feel like mere months or even weeks for you, hurtling through the void at nearly the speed of light. This is due to a phenomenon called time dilation. As an object's velocity increases relative to another observer, its passage of time slows down. It's a peculiar consequence of Einstein's theories, and it underscores just how alien this experience would truly be. The universe outside your window, the distant galaxies, the faint quasars, would appear distorted, their light stretched into long, thin bands due to something known as cosmological redshift. This effect isn't caused by the speed you are traveling at, but rather by the expansion of space itself. As space expands, the wavelengths of light traveling through it also stretch, shifting them towards the red end of the spectrum. The void's emptiness influences this distortion too. The lack of gravitational gradients, the subtle variations in gravity caused by massive objects, means there are no tidal forces to subtly warp space-time around you. It's an incredibly uniform environment, which further isolates you from any sense of place or direction. Imagine trying to navigate a perfectly smooth and featureless plane, with the sun always directly overhead. After some time, you would lose all sense of orientation. There would be no shadows to indicate east or west, no landmarks to define north or south. You would simply drift onward, lost in an endless expanse of nothingness. And that, perhaps, is the most terrifying aspect of the Boötes Void. Not its size, though that's certainly remarkable, but its utter lack of context. It represents a region where the usual rules and patterns of the cosmos seem to break down, a place so empty that it challenges our fundamental understanding of space, time, and motion. It speaks to the possibility that our universe is not neatly organized or uniformly distributed, but rather punctuated by vast regions of near-nothingness, cosmic deserts stretching out between islands of galaxies. The speed of light, typically an indicator of boundless possibility, becomes a measure of frustration within this void. It's still the fastest thing imaginable, yet it's barely enough to traverse the distances involved in any meaningful time frame. The patience required is cosmic, the dedication unfathomable. You would be traveling for eons before reaching another significant gravitational influence, or even encountering a stray galaxy of substantial size, it forces us to confront our own limitations as observers, the inherent biases of our perception, shaped by living within a relatively dense and structured environment like our Milky Way galaxy. We are accustomed to seeing patterns, structures, relationships. We crave context and meaning. The Boötes Void offers none of that. It simply is a vast, silent expanse lacking definition, a testament to the possibility of emptiness on a scale so immense it's difficult to even fathom. To contemplate its volume, imagine all the stars in our galaxy, hundreds of billions of them, compressed into a single sphere. Now picture countless such spheres, each one brimming with starlight and planetary systems scattered throughout this void. And yet, even that astonishing number wouldn't fill it. The Boötes Void would still stretch out beyond those spheres, an unyielding gulf of nothingness. It's a humbling realization, a reminder that we exist within a universe far larger, stranger, and more mysterious than we could have ever imagined. It is a place where our everyday experiences feel so fundamentally irrelevant, so utterly disconnected from the grand sweep of cosmic history. Imagine a spaceship traveling at the speed of light. To cross a single light day takes a full day of blinding speed. In the heart of the Boötes Void, you could travel at light speed for weeks, for months, for years, and the view beyond your window would never change. Not a single photon of starlight would touch your hull. Time itself feels distorted here, without the drift of nearby stars, without the slow turning of any orbit. The universe feels entirely, perfectly frozen, a stillness unlike any other you've encountered presses in, a profound quiet that isn't merely the absence of sound, but something more fundamental. It is as if the very flow of existence has been gently paused. Our perception of time, after all, is irrevocably linked to change. It is built upon the familiar rhythms and motions we experience every day. The gradual arc of the sun across the sky, marking the passage of hours, the shifting seasons dictating the year, the ceaseless dance of planets around their stars, etching out years and millennia. Every breath you take, every thought that wanders through your mind is punctuated by these silent measurements, a constant awareness of movement, progression, transformation. Here within the Boötes Void, however, those familiar anchors are gone. There are no passing stars to track across your viewport, no trails of light recording their journeys against the inky blackness, no planets gracefully orbiting distant suns, never pausing, always circling and reminding you that something is happening. No galaxies swirling with dizzying speed, painting spirals in space as they spin through eons. There are no markers, no reference points, nothing to gauge your progress or lack thereof. The very concept of distance begins to feel different, less a measure of separation and more an abstraction. The emptiness stretches out before you, not just vast, but unyielding. It's easy to think of this absence as simply nothing, an absolute void bereft of all meaning. But that is a profound misinterpretation. It isn't nothingness you find here. It is something else entirely, a state far older and more enduring than the transient movements we so readily perceive in our own corner of the cosmos. Imagine for a moment what it would be like to exist in a place where the universe itself seems to hold its breath. The mind, accustomed as it is to processing continuous streams of information, registering colors, shifting, hearing sounds fading, feeling warmth and cold ebb and flow, begins to struggle when confronted with this absolute uniformity. The absence of change becomes its own kind of force, a gentle but persistent pressure that slowly dislodges the assumptions we take for granted. You find yourself pausing, your internal clock, so reliant on external cues, starts to falter without the steady tick-tock provided by the turning Earth or the orbiting moon, without the predictable rise and fall of day and night. Your sense of time begins to loosen its grip. It's not a sudden disorientation. It's more subtle than that. It is a slow melting away of expectation, a gradual realization that there is nothing to expect. The relentless forward march you thought defined existence fades, revealing a landscape where the past, present, and future seem to blend into an indistinguishable whole. You might find yourself wondering if minutes have passed or millennia. It becomes impossible to say with certainty. This isn't necessarily unsettling, though. In fact, for many, there's a surprising sense of liberation in letting go of time altogether. The pressure to accomplish, to progress, to do something diminishes. The relentless striving that so often defines human experience recedes into the background. You are left simply being, observing, existing within this timeless expanse, without any need for direction or purpose beyond awareness itself. Consider the sheer age of this space. Billions upon billions of years have unfolded here, uninterrupted by the frantic activity of galaxies and stars. The earliest photons ever emitted have traveled across unimaginable distances to reach us, light that witnessed the birth pangs of our universe, the colossal explosions as structures began to form. Many of these ancient particles still drift onward, undisturbed, unabsorbed, carrying whispers of events so distant they are beyond comprehension. The stillness is not merely an absence, it's a preservation. It's as if this region of space has become a cosmic repository, holding onto moments long vanished from the rest of the universe. You are suspended within a pocket of stability, shielded from the ceaseless churn that defines most existence. The laws of physics still apply, of course. Gravity remains constant. Inertia holds firm, but their effects are muted, softened by the sheer scale and uniformity of the void. There's an undeniable feeling of serenity here, a deep and ancient calm that seems to permeate everything. It isn't just the lack of external stimulation. It is something more profound. Perhaps it is the sense of being held within something vast and unchanging, cradled in the embrace of eternity itself. The silence presses close, not as an oppressive weight, but as a gentle invitation, an invitation to surrender to the stillness and simply be present. Imagine that you could somehow perceive the flow of time itself, not as a linear progression, but as a swirling river. In most places you observe, this current rushes onward with relentless force, carrying everything along in its wake. But here, within the Boötes Void, the river seems to have become a vast, placid lake, still and deep, reflecting the distant stars like an infinite mirror. This tranquility extends beyond mere physical stillness. There's a sense of peace. It's not the fleeting contentment that comes from achieving a goal or experiencing pleasure. It is something far deeper, more enduring. It is the absence of conflict, the cessation of struggle, the quiet understanding that everything simply is, without judgment, without expectation. The human mind tends to seek patterns, to find meaning even where none exists. But here, amidst this cosmic emptiness, it's best to resist that urge. There's a certain beauty in accepting the unknowable, in surrendering to the mystery of existence. The void isn't lacking anything. It simply is a vast, timeless expanse holding within it the potential for everything, and yet containing nothing at all. And as you linger here, adrift in this ancient calm, you might begin to experience something akin to transcendence, not in a religious sense, but in the deep understanding that your individual existence is just a fleeting moment within an unimaginably vast tapestry of time and space. The worries, anxieties, and ambitions that so often consume you begin to feel distant and insignificant, mere ripples on the surface of eternity. You are not merely observing the Boötes Void. It is also observing you. Your thoughts ripple outwards into the stillness, momentarily disturbing the surface before fading back into the silence. Your very existence becomes part of this ancient tapestry, a brief spark of consciousness within an ocean of timelessness. There's no need for grand pronouncements or profound insights here. It is enough simply to be, to breathe deeply, to exist in harmony with the stillness, and to allow the immensity of space to wash over you. Let go of your expectations, release your anxieties, and embrace the quiet mystery of the void, for within its depths lies a profound truth. That true peace isn't found in change or progress, but in acceptance, in surrendering to the gentle rhythm of eternity. The universe has been expanding for billions of years. Galaxies have collided, stars have been born and died. Yet here, within this pocket of space, it remains remarkably unchanged. The echoes of the Big Bang still reverberate through the cosmos, but they barely register here, muted by the sheer scale of the void. This place is a witness to the grand procession of time, an untouched archive holding secrets older than stars themselves. And as you float silently in its embrace, you realize that somewhere deep within your being, something shifts, a subtle realignment of perspective, a quiet acceptance of the vastness and mystery that surrounds you. The terrifying emptiness transforms into something else entirely, into a realm of profound stillness, ancient wisdom, and enduring peace. It is a place where time loses its power, where existence becomes pure awareness, and where you are both utterly insignificant and infinitely connected to everything in the universe. The silence within the Boötes Void stretches deeper than you might initially comprehend. It is a silence not merely of sound, but of substance. We've spoken about its vastness, its utter lack of visible structure when compared to the vibrant tapestry of the cosmos beyond, and how that very emptiness can act as a kind of quietude for the mind, a place to simply be. Yet, what truly sets this region apart, what generates an unsettling feeling in many who contemplate it, isn't just the absence, but the difference between what we expect to find and what we actually observe. You see, our understanding of the universe is built upon models, increasingly sophisticated maps drawn from countless observations and elaborate calculations. These models are not mere guesses. They are grounded in established physical laws like gravity and the expansion of space itself. And they tell a particular story about how matter should be distributed throughout the cosmos. The prevailing theory dictates that galaxies, those swirling islands of stars, gas, dust, and dark matter tend to clump together into larger structures, vast filaments and walls stretching across billions of light years, interwoven with colossal voids like the one we're exploring now. These structures are a consequence of density fluctuations in the very early universe. Tiny variations that grew over eons under the pull of gravity. Based on these models, considering its sheer size, a sphere nearly 200 million light years across, the Boötes Void should be teeming with galaxies. We're talking about an estimated 10,000 or more galaxies within this volume of space. The idea seems almost intuitive. If you were to simply scale down the average density of galaxies in our observable universe, applying that ratio to the void's dimensions, it points to a surprisingly robust population. Imagine a cosmic city, not entirely deserted, but still sparsely populated. A sense of quietude maintained by millions of distant lights blinking across the darkness. However, when astronomers have actually looked at this region using powerful telescopes like those on board the Hubble Space Telescope, and now the James Webb Space Telescope, the reality is starkly different than what these models predict. Instead of thousands of galaxies, surveys so far have identified a mere 60 or so. 60 galaxies in a volume of space that could contain 10,000. It's a discrepancy that has puzzled astronomers for years. A cosmic anomaly that challenges our assumptions about how the universe should be arranged and raises profound questions about whether we truly understand the forces shaping its large-scale structure. It's important to clarify that these galaxies aren't hidden. They haven't simply drifted behind some vast, unseen curtain of dust or gas. The void is remarkably transparent. One can observe through it with relative ease. They are not obscured by some localized phenomenon. No, the missing galaxies weren't merely hiding. The startling truth appears to be that they were never there in the first place. This realization shifts the unsettling nature of the void itself. At first glance, a perfectly empty space might seem the most perplexing. A cosmic absence defying explanation. But an almost empty space is somehow stranger still. It implies an active process, a rejection of expectation, as if something more fundamental than mere emptiness were at play. Think about it for a moment. Our models are based on the distribution of matter as we observe it across most of the observable universe. They rely on patterns and trends gleaned from countless galaxies and clusters. When we extrapolate these patterns to the Boötes Void, we're essentially saying that the rules governing cosmic structure should apply everywhere. Yet this region appears to be an exception, a place where those rules simply don't hold true. So what could cause such a significant deviation? There are several hypotheses, although definitive answers remain elusive. One possibility is that the void formed very early in the universe's history, perhaps as a result of fluctuations in the density of dark energy. The mysterious force driving the accelerated expansion of space. These fluctuations might have suppressed galaxy formation in this region, preventing gas from collapsing under gravity to form stars and galaxies. Another idea suggests that the Boötes Void could be a remnant of an earlier epoch, a cosmic bubble created by some even more ancient process we don't yet fully understand. In some models of inflation, the theory describing the incredibly rapid expansion of the universe in its first fraction of a second. Certain regions might have expanded much faster than others, creating vast voids that are still visible today. These voids may essentially represent areas where matter was squeezed out during this period of accelerated growth. It's also possible that our models themselves need refinement. Perhaps we're missing some crucial ingredient or principle that governs the formation and distribution of galaxies in these extreme environments. Something related to dark matter, perhaps, which remains one of the greatest mysteries confronting modern cosmology. Dark matter, you recall, constitutes about 85% of all matter in the universe. Yet its nature is still largely unknown. Its gravitational influence shapes the cosmos, but it doesn't interact with light, making it incredibly difficult to detect directly. It could be that the way dark matter behaves within voids differs from what we currently assume, influencing galaxy formation in unexpected ways. The implications of this cosmic anomaly are far-reaching. The Boötes Void isn't just a peculiar feature of our universe. It's a window into the fundamental laws that govern its evolution. It challenges us to reconsider our assumptions and search for new physics to explain the observed discrepancies. And beyond the scientific intricacies, there's something deeply humbling about facing such an overwhelming expanse. A space where even our most sophisticated models falter, reminding you of the sheer immensity and complexity of the cosmos. To stand before this vastness is to be confronted with a profound sense of scale. To understand your own place within the grand narrative of existence. It's a humbling perspective, and one that allows for a quiet, contemplative moment, a chance to reflect on the beauty and mystery of creation, a space where you can truly connect to the immensity surrounding you. Perhaps it is in these moments, surrounded by the echoing silence of such a vast region as this void, when we are able to best appreciate the delicate balance between being an insignificant speck in a boundless cosmos and simultaneously belonging to something breathtakingly grand. The void is not entirely empty, and that somehow makes it stranger. Our models suggest that a region this size should cradle perhaps 10,000 galaxies. So far, we have found only around 60. The relative scarcity of galaxies within the Boötes Void lends it a profound character. These are not just distant islands, but solitary ones. Imagine yourself adrift on an ocean with no land in sight, a feeling that echoes the experience for any galaxy residing within this cosmic expanse. The density of galaxies here is so extraordinarily low that each one exists in a state of near total isolation, effectively alone amidst a backdrop of unimaginable emptiness. They are scattered across a volume of space larger than our entire Milky Way galaxy, plus its surrounding halo. It's difficult to grasp the scale involved, even when equipped with mathematical descriptions. Consider the distances separating these galactic islands. From any given point within one of those galaxies, perhaps from a planet orbiting a sun not unlike ours, the nearest large neighbor could lie tens of millions of light years away. That's an unimaginable gulf. To put it in perspective, the Milky Way has dozens of satellite galaxies within 50 million light years, and those are considered close by cosmic standards. Think about that distance for just a moment. Light, traveling at its incredible speed, would require tens of millions of years to traverse the space between these galactic solitudes. Each photon emitted from one galaxy might be destined to wander through the void for eons before encountering another celestial body. It's easy to become lost in contemplating such distances. But let's consider what it might be like to live within one of those galaxies. Imagine a civilization evolving on a world orbiting a star within this isolated galactic haven. They would observe their own galaxy, a swirly disk of stars and gas perhaps, and, lacking any evidence to the contrary, they might reasonably conclude that it constitutes the entirety of existence. Their telescopes would reveal only the familiar patterns of their home galaxy. There would be no hint that other galaxies, vastly different yet fundamentally similar, existed far beyond their sight. They'd have no concept of galactic clusters, superclusters, or even the vast cosmic web that interconnects them, all because they are simply too far removed from any interaction with those structures. The implications are truly mind-boggling. Their understanding of the universe would be fundamentally limited by this extreme isolation. Perhaps they might develop sophisticated theories to explain their seemingly boundless domain. Theories perfectly consistent with their observations, yet entirely divorced from the reality of a much grander cosmos. They could build complex civilizations pursuing unique technologies and philosophies, all without any awareness of other possibilities that lie hidden in the darkness beyond. In essence, they would be cosmic hermits, dwelling within an island galaxy in a boundless ocean of nothingness, unaware of their true context. The sheer scale of this isolation is almost impossible to truly imagine. We tend to think in terms of our own lives, our own planet, our own solar system. These are the scales that define our everyday experience. But when confronted with distances measured in millions or even billions of light years, our intuition fails us. It's a realm where concepts like near and far lose their familiar meaning. They become almost meaningless abstractions. It's worth pausing here to consider what this means for the fundamental processes that shape galaxies. Galaxies grow through mergers, collisions, and close encounters with other galaxies. These interactions trigger bursts of star formation, reshape galactic structures, and ultimately influence how they evolve over long time spans. But within the Boötes Void, these opportunities are exceptionally rare. The galaxies drift along their trajectories, essentially untouched by outside influences. They evolve in relative peace, following paths dictated predominantly by the initial conditions set shortly after the Big Bang. The subtle density fluctuations that seeded the universe's larger structures. This lack of mergers can lead to a rather bland evolutionary trajectory for these galaxies across cosmic timescales. Star formation rates tend to be lower than average. They rarely experience dramatic transformations. They are, in many ways, relics of an earlier epoch, snapshots from a time when the large-scale structure of the universe was still forming. Were we able to travel back billions of years? It's likely that these galaxies would have been more densely packed, part of a protostructure that later dispersed under the relentless pull of expansion. They've become isolated because the intervening space, the volume between them and their former neighbors, has steadily expanded ever since. You might wonder if this relatively undisturbed state presents an opportunity to study how galaxies evolve in isolation. To better understand what factors govern their long-term development without the disruptive influence of mergers or tidal forces. And indeed, that is one area of active research. By comparing these solitary galaxies with those residing in denser environments within galactic clusters or groups, astronomers can gain insights into the relative importance of different evolutionary pathways. However, observing them directly presents a significant challenge. The distances involved are so vast that even the most powerful telescopes struggle to gather sufficient light to reveal their finer details. We primarily observe them as faint points in the sky, making it difficult to discern subtle differences in their properties. Another perplexing aspect of the Boötes Void is its very existence, its sheer emptiness. Why does such a large volume of space contain so few galaxies? There are several potential explanations, but none are entirely satisfactory. One possibility is that it represents an underdense region, a pocket of space where matter failed to collapse into galaxies as effectively as in other regions of the universe. This could be due to random fluctuations in the early distribution of dark matter. The invisible substance that makes up about 85% of the universe's mass and plays a crucial role in structure formation. Dark matter clumps together, acting as gravitational seeds around which ordinary matter can coalesce into galaxies. Perhaps within this region, the initial density fluctuations were unusually low, preventing the formation of a significant number of galaxies. Another intriguing idea involves the possibility that a massive object, perhaps a dark matter halo significantly larger than our own Milky Way, could have gravitationally dispersed any galaxies that might have formed in its vicinity. This hypothetical structure would not necessarily be visible to us directly, as it would primarily consist of dark matter. However, its gravitational influence could extend far beyond its physical boundaries, preventing the formation of new galaxies and even ejecting existing ones from the region. essentially carving out a void. Still, another possibility is that the Boötes Void was simply cleared out by some long ago cosmic event. Perhaps a large-scale interaction with a nearby structure, or an unusually powerful burst of energy that disrupted galaxy formation. However, finding definitive evidence for such events remains elusive. These are complex questions that require sophisticated cosmological simulations and detailed observations to fully understand. And the Boötes Void continues to challenge our understanding of how the universe's large-scale structure has formed over billions of years. And so we return to the profound sense of isolation fostered by this cosmic emptiness, a feeling compounded by its sheer scale. It is a region where the laws of physics operate in relative tranquility, where galaxies drift along their trajectories as if suspended on still waters, and where any civilization encountering it might be tempted to believe themselves alone in a boundless universe. The Boötes Void isn't just a vast expanse of space. It's an existential thought experiment, offering a glimpse into the possibility of solitude on a scale almost too grand for human comprehension. It invites us to consider what it means to belong or not to belong within the vastness of all that exists. In this expanse, galaxies are cosmic hermits. If the Milky Way had formed here, at the center of the Boötes Void, we would not have learned that other galaxies existed until the 1960s. The night sky from a world inside the void would be an endless, terrifying black canvas. No stars, no neighboring clouds of light. Just a single, solitary island, adrift in a dead and silent ocean. And yet, to truly grasp the nature of this void, it's worth imagining a more intimate perspective. What might you see if you were standing on a world nestled deep within its boundaries? Picture yourself there, a landscape sculpted by unimaginable stillness, bathed in the quietest light imaginable. The very air, should it exist, would hold an uncanny tranquility, undisturbed by the constant bustle of stellar winds and cosmic radiation that permeate much of the universe. lift your gaze toward the night sky, a sight so alien, so profoundly different from anything you've ever known, that its initial impact might be difficult to process. The first thing, perhaps the most disorienting thing, would be the absence, an almost complete lack of light. From Earth, even on the darkest nights, there's always something visible, a smattering of stars. The faint glow of the Milky Way stretching across the horizon. The occasional meteor flash cutting through the darkness. But here, within this cosmic chasm, much of that vanishes entirely. The overwhelming majority of what you'd perceive would be nothingness. A black so absolute, so pure, that it almost feels palpable. A physical weight pressing down on your senses. You see, galaxies aren't randomly scattered across the universe like grains of sand on a beach. They cluster together in vast networks, filaments, and sheets connected by gravitational ties. These are the pathways along which matter flows, drawn together over billions of years to form larger structures we call superclusters. Our own Milky Way is part of such a network, the local group, a relatively small collection of galaxies bound together by gravity. And the local group itself resides within the Virgo supercluster, one of the largest known concentrations of galaxies in our observable universe. But the Boötes Void sits outside these networks. It's a region where these filaments thin out and disappear entirely, leaving behind vast expanses, regions of essentially empty space that defy easy explanation. Light still travels through this void. Photons from distant quasars continue their journey across billions of light years, unaffected by the absence of galaxies. But those photons are traveling through almost nothing. There are so few sources of light within the void that its vastness becomes nearly impossible to comprehend. And that's what would be apparent when you look up: an extraordinary emptiness. No familiar constellations, the comforting patterns we've traced across Earth's sky for millennia. No sprawling Milky Way band streaking overhead, a reminder of our own galactic home. Instead, just darkness, uninterrupted expanse of black so profound that it verges on the unsettling. The sheer scale is difficult to grasp from afar. Numbers and measurements fail to truly convey what it would be like to directly experience such vast emptiness. Consider this. If you were standing in the void, looking out at the observable universe, the nearest galaxy visible to your unaided eyes, and that's a significant if, would likely be our own Milky Way, appearing as just a faint, fuzzy patch of light against the stark blackness. It would seem shockingly small and distant, an isolated beacon in what otherwise seems like an infinite ocean of nothingness. The light from our home galaxy is incredibly dim when viewed from that distance, stretched and attenuated by the intervening space. The void's sheer size means that even galaxies far beyond our own become effectively invisible, swallowed up by the overwhelming darkness. Imagine trying to spot a single firefly on a moonless night in a vast desert. That gives you some sense of the difficulty involved in perceiving anything at all within this cosmic emptiness. To be clear, it wouldn't be perfectly black. The cosmic microwave background, the faint afterglow of the Big Bang, would still permeate everything, providing a subtle, uniform illumination. It's an incredibly weak signal, too dim to be easily perceived by human eyes. But its presence would add a ghostly, ethereal quality to the darkness, akin to seeing only the faintest glimmer from what seems like an endless night sky on Earth during a new moon phase. But beyond that background hum, the vast majority of any light you detect would originate from our own galaxy. A singular point of light in an otherwise featureless void. And even that wouldn't be constant. The Milky Way itself is a dynamic and ever-changing structure. Its spiral arms rotate, stars are born and die, supernovas erupt, and all of this activity subtly alters the amount of light reaching you. At times, the Milky Way might appear brighter, shining with intense energy. At others, it might seem to fade into the background, becoming a fainter and more distant presence. It would be a lonely sentinel in a sea of darkness, a constant reminder of your isolation. It's tempting to think that such an environment would instill feelings of terror, a primal fear of the unknown, amplified by the sheer scale of the void. And undoubtedly, there would be a sense of disorientation and vulnerability. The lack of familiar landmarks could lead to a feeling of being utterly lost, adrift in an endless ocean of nothingness. But it's also conceivable that such a sky might evoke a profound sense of peace, a quietude so absolute that it transcends fear. The absence of light pollution, the artificial glow we've become accustomed to on Earth, would be breathtaking. No city lights disrupting the darkness, no aurora borealis dancing across the sky, just pure, unfiltered blackness stretching in all directions. And as your eyes adjusted to the faint glimmer of the Milky Way, you might begin to perceive subtle variations in the background illumination. A hint of structure hidden within the void's apparent emptiness. Perhaps you'd notice the slight distortions caused by gravitational lensing, the bending of light around massive objects that lie between you and distant galaxies, a phenomenon that would become strikingly visible against the stark backdrop of the void. It's worth considering, too, how such a sky might shape the understanding of those who observed it over vast stretches of time. Imagine an ancient civilization emerging on one of the hypothetical worlds, nestled within this expansive emptiness. Their cosmology would be radically different from ours. A universe dominated by darkness and defined by the singular presence of their own galaxy. They wouldn't have the benefit of seeing countless neighboring galaxies clustered together in superclusters and filaments. Their view of the cosmos might lead them to believe that their galaxy was the only one that existed, or at best, a lone island within an otherwise empty universe. The concept of galactic clusters or superclusters could be entirely alien to them. They would likely develop different theories about the origin and structure of the universe. Theories shaped by the unique perspective afforded by their location within this cosmic void. Their science might focus on understanding the properties of darkness itself, its effects on gravity, light propagation, and the distribution of matter in ways that we can scarcely imagine from our vantage point within the bustling local group. Looking up at such a night sky would fundamentally alter one's perception of reality. A profound shift in perspective that transcends mere aesthetics. It's an experience so unlike anything we know on Earth that it challenges our assumptions about the universe and our place within it. And as you stood there, bathed in the faint light of your home galaxy, contemplating this immense emptiness, a deep sense of humility might settle over you. A realization of just how small and insignificant we are in the grand scheme of things. It would be an experience both terrifying and awe-inspiring. A reminder that the universe is far stranger, more vast, and more mysterious than we can ever fully comprehend. Perhaps it's this very unknowability, this profound emptiness, that holds some of its greatest secrets. And so, a single galaxy sits before you now, a quiet island of warmth and light, suspended within an ocean of darkness, unlike any you've likely imagined. It's remarkable just to consider, isn't it? That these galaxies, each one containing hundreds of billions of stars, planets perhaps teeming with life, are not scattered randomly throughout the cosmos, but instead gathered into vast structures, filaments really, interwoven across unimaginable distances. And then there are voids like this one, the Boötes Void, a space so shockingly empty it fundamentally alters our understanding of how the universe is arranged. We're positioned here now, hovering just at the very edge of one of its galaxies. It's a view that offers both comfort and an almost unbearable sense of scale. The light from those distant stars drifts towards you. Ancient photons carrying tales of nuclear fusion and planetary orbits. A snapshot of existence frozen in time. Think about that for just a moment. Every glimmer reaching your eye began its journey millions, perhaps billions of years ago. It's It's passed through an expanding universe, been stretched and redshifted by the relentless flow of space-time. And still it arrives here, bringing with it the faint echoes of a past so distant it struggles to fit in our minds. But beyond that edge, there is absolutely nothing like it. No gentle glow, no subtle haze, just absence. A gulf so wide, so profoundly empty, that words truly fail to capture its immensity. You know, we talk about distances in space using light years, a measure of how far light travels in 1 year. Approximately 9.5 trillion kilometers. It's an attempt to make these cosmic scales more digestible for us humans who are so accustomed to measuring things in meters or miles. But even that familiar unit struggles to convey the sheer emptiness of somewhere like the Boötes Void. It's not simply a matter of traveling across a few light years, or even hundreds. It's a journey into an abyss where the next galaxy lies tens of millions of light years away. Consider what that means practically. Imagine you could travel at the speed of light, an impossible feat for anything with mass, but useful for these thought experiments. And you set off in a straight line toward that other galaxy. It wouldn't be a quick trip. You'd be traveling for an unimaginable span of time, longer than the entire history of human civilization, longer than the existence of our species, even. And as you journeyed through this vast emptiness, you would see, well, nothing. No stars, no any Beuli, not so much as a stray dust grain. Just endless blackness, unbroken and absolute. A space where matter is extraordinarily scarce, far less dense than many interstellar clouds we observe elsewhere. It's difficult to conceptualize, isn't it? Our brains have evolved to navigate the world around us, to perceive depth, distance, and density based on our relatively limited physical experience. We use familiar cues like overlapping objects or changes in light intensity to construct a three-dimensional representation of our surroundings. But these kinds of reference points simply disappear in the face of such vast emptiness, leaving you adrift in an ocean of pure nothingness. It's not just that the distance is far. It's that there's so very little to look at across that distance. And yet, within this unsettling expanse, something extraordinary emerges. A strange and solemn kind of beauty. Because when you remove all familiar reference points, when you strip away the clutter and complexity of the universe, you are left with a profound clarity. The darkness becomes more than just an absence. It becomes a canvas upon which the faint light of distant galaxies can truly shine. Each point of brightness, each isolated island of warmth, appears almost impossibly vibrant against this backdrop. It's like gazing at stars through the clearest mountain air. A purity and sharpness that is rarely experienced elsewhere. Scientists are still working to understand why these voids exist and how they came to be. The prevailing theory suggests that they arose in the very early universe during a period of rapid expansion known as inflation. During this epoch, quantum fluctuations, tiny random variations in density, were amplified on an enormous scale, creating regions where matter was slightly less dense than average. These areas gradually grew over billions of years, pulling galaxies toward themselves through gravity, whilst simultaneously pushing them away due to the universe's constant expansion. It's a complex interplay of forces that resulted in this lacy pattern of filaments and voids, a cosmic scaffolding that dictates how everything is distributed across the observable universe. The Boötes Void itself is particularly striking, being one of the largest known voids. It spans approximately 330 million light years across. That's larger than our entire local supercluster of galaxies, which contains hundreds of thousands of galaxies, including our own Milky Way and Andromeda. And what makes it even more remarkable is its relative emptiness. The average density of matter within the void is less than 1 atom per cubic meter, a vacuum far greater than anything achievable in a laboratory on Earth. To put that into perspective, the air you breathe contains roughly 5x10 sup 19 /subatoms per cubic meter. So, within this enormous space, there's almost nothing at all. It's easy to be intimidated by such vastness, to feel insignificant and dwarfed by the scale of the cosmos. But perhaps there is something liberating about it too. When you look out into that emptiness, when you confront the sheer enormity of space, you are forced to reconsider your place in the universe. You realize that humanity, with all its ambitions and achievements, is but a tiny speck on an infinitesimally small island of light within this vast ocean of darkness. But it's also worth remembering we have spent millennia looking up at the night sky, asking questions about what lies beyond. It took us eons to develop the tools, telescopes, spacecraft, complex mathematical models, to even begin answering those questions. And now, thanks to incredible advancements in astronomy and cosmology, we are beginning to glimpse the true nature of the universe, its vastness, its emptiness, and its profound beauty. Consider this: that faint light traveling toward you now has traversed distances so vast it defies our everyday comprehension. It reminds us how much time and energy it takes to travel through the cosmos, and how much more there still is to explore. You might feel a sense of sadness thinking about all this empty space, but embrace the quiet solitude. Think instead that within each galaxy lies countless possibilities life waiting to be discovered. Worlds yet unknown awaiting exploration. There's wonder here to be found, not just in the stars themselves, but also in the sheer scale of what separates them. And as you gaze into the darkness, allow yourself to simply be, to appreciate the quiet majesty of this cosmic landscape, a place where even emptiness can inspire awe and reflection. For within that vast expanse lies a profound truth. We are connected to everything, woven together by the very fabric of space and time itself. And while we may be small in terms of physical size, our capacity for wonder, our yearning to understand the universe around us, is truly boundless. It's this curiosity, this relentless pursuit of knowledge that sets us apart and allows us to marvel at the breathtaking beauty of the cosmos, even when it stares back at us with an unsettling emptiness. And so we're left to ponder a question far more profound than just what the Boötes Void is. Why does it exist at all? Because, you see, a region of space this vast, this utterly devoid of galaxies, simply shouldn't arise easily from the ordinary workings of the cosmos. The universe, on the grandest scales, tends toward an even distribution of matter. Galaxies cluster together, forming walls and filaments within a vast network. The cosmic web we spoke about earlier. But these structures are intimately intertwined with voids. Yes. But never to this staggering degree. To find something so extraordinarily empty, it suggests forces at play that we don't fully understand. Processes beyond our current comprehension of how things come together in the universe. Scientists have proposed several explanations for the Boötes Void's existence. And what's remarkable is just how different these theories are. They stretch outward towards vastly differing visions of reality itself. Some delve into the early stages of cosmic evolution, seeking to understand how primordial density fluctuations might have given rise to such an anomaly. Others explore more exotic possibilities, drawing on ideas from inflation theory, and even invoking the possibility of parallel universes bumping against our own. No single explanation is currently accepted as definitive. The Boötes Void remains a captivating enigma. A puzzle box challenging us to refine and expand our understanding of the universe's fundamental laws. Consider, for instance, the idea that the void formed through a process called cosmic density fluctuations during the very early moments after the Big Bang. In those first fractions of a second, tiny variations in the density of the nascent universe rippled outward. Some regions slightly denser than others. These tiny seeds became the gravitational attractors that eventually coalesced into galaxies and galaxy clusters. The theory suggests that somewhere along the way, an exceptionally large fluctuation, a substantial underdensity, occurred in this early soup of energy. This region, instead of attracting matter, actively repelled it. Effectively pushing all surrounding material outwards over billions of years, carving out this enormous empty bubble. It's something like imagining blowing up a balloon as you inflate it. The rubber stretches and thins in certain areas, creating larger spaces. The early universe did something similar, but on an incomprehensibly grand scale. However, simulating these early density fluctuations is incredibly complex. How could one fluctuation become so significant as to create a void of this size? Critics point out that even the most sophisticated models struggle to convincingly replicate such an extreme outcome. It feels almost improbable. The sheer scale of it defies easy explanation through purely gravitational interactions happening over cosmic time. Then there's the concept relating to inflation theory, which itself is a cornerstone of modern cosmology. Inflation posits that in those initial moments, the universe underwent a period of incredibly rapid expansion. Far faster than the rate we observe today. This exponential growth stretched tiny quantum fluctuations, random movements at the smallest scales into vast cosmic structures. It's like taking a single ripple on a pond and suddenly magnifying it to encompass an entire ocean. Perhaps some theorists suggest this inflationary epoch produced pockets of space that experienced even more rapid expansion than the rest of the universe. These regions would have effectively blown up their surrounding areas, creating colossal voids. This explanation is alluring because it ties the void's existence to a well-established cosmological framework: inflation. However, it raises its own set of challenges. We still don't fully understand the details of inflation itself. Including what drove that rapid expansion or how it eventually stopped. Moreover, predicting exactly how those inflationary fluctuations would have manifested in such large structures as the Boötes Void is proving difficult. It's a fascinating idea. The prospect that our universe's emptiness stems from a period of mind-boggling expansion. But more work is needed to solidify its potential role in the void's formation. A still more speculative, yet intriguing explanation involves multiverse theory. The concept of multiple universes coexisting alongside our own has captivated both scientists and science fiction writers for decades. If those separate universes have different physical constants or operate under slightly altered laws, then it's conceivable though highly improbable. That a collision between two such universes could leave a mark on ours. Picture two soap bubbles gently merging. The point of contact creates an area with altered thickness and shape. A similar event, occurring across vast distances in space-time, might have created a region where matter was pushed outwards, forming a void. This notion, while dazzlingly imaginative, is also intensely difficult to test. The existence of parallel universes remains firmly within the realm of theoretical physics. A possibility suggested by some mathematical models, but not yet directly observable. If such a collision truly shaped the Boötes Void, then it would be a profound revelation about nature's deepest secrets. Evidence of other realms beyond our own cosmic bubble. But confirming it, providing tangible proof for this grand idea. Would require breakthroughs far beyond our current capabilities. Beyond these are the theories that propose the void isn't actually empty, but contains structures too faint or distant to detect with our current instruments. Perhaps there are dwarf galaxies, their light hopelessly dimmed by cosmic distances. Hidden within the Boötes Void's expanse. Or maybe dark matter, the mysterious substance that constitutes approximately 85% of the universe's mass. Is distributed in a peculiar way within the void. Creating a gravitational scaffolding that we haven't yet fully understood. It's possible, too, that our understanding of dark energy that force driving the accelerated expansion of the universe. Needs further refinement to account for this phenomenon. Perhaps it is more complex than we currently assume and has manifested in ways affecting vast areas like the Boötes Void. Regardless of the explanation's eventual form, each avenue of inquiry points towards a deeper appreciation for the scale and complexity of the cosmos. And our limited grasp on its fundamental forces. The fact that a region as seemingly simple as an empty space can evoke such profound questions indicates that we're still missing crucial pieces of the puzzle. And perhaps the most remarkable thing about contemplating the Boötes Void is not finding a definitive answer, but recognizing the sheer scale of our ignorance, the vastness of what remains unknown. It's a humbling perspective, one that reminds us that even with all our scientific endeavors, we've only scratched the surface of cosmic understanding. The mystery of the Boötes Void serves as a powerful reminder. The universe is full of surprises. And its grand design is far more intricate than anything we could have initially imagined. It invites us to be patient in our exploration, open to new ideas, and constantly willing to revise our assumptions in light of emerging evidence. That's how science progresses. Through an ever-expanding circle of inquiry. The search continues, the questions deepen, and as we gaze out into those ancient, empty spaces, and attempt to unravel their secrets, we expand not only our knowledge, but also our appreciation for the humbling grandeur of existence. For now, the Boötes Void remains a giant question mark in the cosmic tapestry. An invitation to explore the boundaries of our understanding and challenge ourselves to imagine realities beyond what we've already encountered. It is ultimately a testament to the enduring power of curiosity. The same flame that has guided humankind's exploration from early observations of the night sky to modern telescopes peering into the farthest reaches of space. And it encourages us to remember, sometimes the greatest discoveries aren't about finding answers, but appreciating the profound beauty in the unanswered questions themselves. And sometimes those unanswered questions lead us to something even more remarkable than finding an answer. They reveal a landscape of absence, a profound lack that expands our understanding of what is by highlighting what isn't. It's tempting to think of the universe as evenly distributed. A sort of cosmic soup of matter and energy. But if you were to journey out beyond the familiar galaxies, far past even those sprawling clusters we know so well, you would find something quite unlike that image. You would encounter voids, vast, seemingly empty regions stretching for hundreds of millions of light years across. These aren't simple gaps. They are substantial spaces where the density of matter is significantly lower than average. A cosmic vacuum compared to the bustling activity around them. And what's even more surprising isn't simply the existence of these voids, but how common they actually are. Our Our universe is riddled with them, countless bubbles of relative emptiness scattered throughout its expanse. We often think of structures forming in space as an aggregation process. Gravity pulling matter together to create galaxies and clusters. But voids demonstrate a different kind of cosmic formation. One driven by the gentle push and pull of dark energy and the subtle influence of gravity's inverse effect. Now, it's easy to imagine these vast voids as primordial entities, singular, unchanging pockets of nothingness that have always existed just as they are. But recent theories suggest a far more gradual and arguably even more fascinating picture, that these enormous voids aren't necessarily born fully formed, but rather coalesced over billions of years from smaller, previously existing voids. Think of it like this. Imagine tiny bubbles forming in a glass of champagne. Each one relatively isolated, surrounded by the effervescent liquid. Now picture those bubbles slowly drifting toward each other, drawn together by currents within the fluid. As they come into contact, their boundaries blur, merging to form larger and more complex structures. The process happening across cosmic scales is similar. Albeit far slower and governed by very different forces. Smaller voids are common throughout the universe, much smaller than the Boötes Void, of course. We're talking about regions, perhaps tens, or even hundreds of millions of light years in diameter, that still possess significantly lower densities of matter than their surroundings. These smaller voids aren't perfectly isolated. exist within a cosmic web where galaxies and clusters are interconnected by filaments of dark matter and gas. And over vast stretches of time, these neighboring voids can gradually drift towards one another. It doesn't require any dramatic event or sudden collision. The movement is incredibly slow, mere fractions of a millimeter per year on average. But the universe offers an astonishing amount of time. Nearly 14 billion years have passed since the Big Bang. And that's ample opportunity for even these tiny shifts to accumulate over colossal distances. As each void drifts closer to its neighbor, they subtly influence one another's gravitational fields. The edges of the voids are where this interaction becomes most apparent. Normally, gravity would be pulling matter into galaxies and clusters, encouraging their growth. But at the boundaries of a void, there's less matter to begin with. So, when two voids approach each other, something counterintuitive happens. The lack of mass actually generates a kind of repulsive force. It's not an active repulsion in the way we might think of pushing something away. Instead, it's more like the gravitational influence is lessened on either side. Creating space where matter used to be drawn inward. As the neighboring voids draw nearer, the areas surrounding them become regions of diminished gravity. Gently nudging any nearby matter outward toward their edges. This isn't a violent expulsion, mind you. It's a gradual and subtle redistribution. Galaxies don't explode outwards or get flung into deep space. Rather, they experience a slight deceleration as they approach the void boundary, subtly shifting their trajectories. And smaller clumps of gas and dust are more readily influenced by this gentler force. Slowly dispersing outward, thinning out the density of matter in that region. Consider it like a cosmic game of billiards. But played over billions of years, with incredibly subtle forces at play. As two voids continue to merge, this process intensifies. The combined boundaries exhibit an even stronger effect. Pushing matter further outwards and creating an ever larger volume, seemingly devoid of significant density. And here's where the beauty of this theory really shines. It doesn't require any extraordinary or unexplained mechanisms. It simply suggests that voids, like galaxies and clusters, are not static features, but rather dynamic structures evolving over time. This is a process driven by fundamental forces acting across cosmic distances, governed by known physics. The leading idea now is that what we observe as these massive structures like the Boötes Void aren't primordial entities, but rather the cumulative result of countless smaller voids merging and growing throughout the universe's history. It's a remarkably elegant explanation for their existence. Turning what might initially seem like an anomaly into another example of cosmic structure formation. And it highlights how even seemingly empty spaces play a crucial role in shaping the large scale. Distribution of matter in our universe. Think about the implications of this grand merging process. The Boötes Void with its staggering size. Likely represents the result of billions or even trillions of smaller voids slowly joining together over cosmic timescales. Each one having played its part by gently redistributing material and creating a region of exceptional emptiness. And as these mergers continue, albeit at an incredibly slow pace, the universe will continue to evolve, constantly reshaping itself through this delicate dance of gravity and dark energy. It's comforting in a way to consider the universe not as a rigid and unchanging structure, but as a dynamic system perpetually engaged in a process of evolution and transformation. It reminds us that even seemingly permanent features, like voids or galaxies, are themselves subject to change over vast timescales, and perhaps most profoundly, it offers a glimpse into the immense power of slow processes acting over billions of years. A timescale beyond anything we can readily comprehend on our own planet. Sometimes the grandest forces aren't about explosive events and dramatic collisions, but rather about the patient accumulation of tiny shifts. Subtly reshaping the cosmos in ways that are both beautiful and profoundly mysterious. Now, as you settle back into your thoughts, perhaps imagining those countless voids drifting across the eons, remember that even in a region seemingly devoid of substance, there's a story unfolding. A subtle narrative written in the very fabric of space itself. The first idea is the gentlest. In this picture, the void is the work of deep time. countless smaller bubbles of empty space born in the early universe. Drifted slowly toward one another over billions of years and merged into one vast emptiness. Pushing the galaxies outward toward its edges. The way soap bubbles gather and join in a quiet sync. And so, we find ourselves amidst this extraordinarily sparse region of space. A cosmic absence, unlike almost anything else we know. It's tempting to simply accept it. To understand its vastness as a natural consequence of how the universe unfolded. The result of random fluctuations in density during the early moments after the Big Bang. Yet, for all its apparent simplicity, something about this emptiness feels different. Its scale is so extreme, its uniformity so unsettling, that it sparks questions beyond simple explanation. Questions that push us to consider possibilities far removed from conventional astronomy. It's human nature to seek patterns, even where they might not truly exist. To find meaning in the seemingly random arrangement of things. And within the context of our own burgeoning understanding of advanced civilizations. A field known as astrobiology and speculative cosmology. One theory concerning the Boötes Void has emerged that defies easy dismissal. Although it remains firmly in the realm of thought experiment, rather than confirmed scientific discovery. This idea stems from something called the Kardashev scale. A hierarchy developed by Soviet astronomer Nikolai Kardashev back in 1964. It's a way to categorize civilizations based on their technological advancement and, crucially, the amount of energy they utilize. At its most basic level, a type I civilization the kind we are currently aspiring toward with our fossil fuel dependency is able to harness all of the energy that falls upon its home planet from its star. A type Roman II civilization, more ambitious still, would be capable of harnessing the entire energy output of an entire star. This might involve some sort of Dyson sphere, a megastructure built around a star to capture nearly all of its emitted light and heat. And finally, a type Roman III civilization, truly beyond our current comprehension. Could harness the energy output of an entire galaxy. The Kardashev scale isn't just about technological prowess. It hints at the evolution of civilizations over vast timescales. Each jump in classification represents an exponential leap in engineering capabilities and resource management. Now, consider what a type Roman II or even a type Roman III civilization might do with access to such extraordinary power. They wouldn't necessarily use it for interstellar warfare. Or grandiose displays of power as science fiction often portrays. Rather, they might dedicate their energy efforts to more subtle goals, to altering the fundamental structure of space itself. Manipulating light and matter in ways that are currently beyond our ability even to conceive. And here's where the Boötes Void becomes particularly intriguing. Imagine a civilization so advanced so far beyond our own understanding. It seeks to control the flow of light throughout its domain. Perhaps they are attempting to create regions of perfectly unperturbed space, shielded from external radiation or cosmic events. Or perhaps they are creating vast energy storage areas, effectively harvesting the light and heat spilling out into the intergalactic medium. One possibility, though exceedingly speculative, is that such a civilization constructs massive, spherical shells. Structures so enormous that they encompass entire stars to capture their radiant output. These shells would be nearly perfect reflectors, designed to contain entirely within themselves the energy of the star they enclose. If you were to observe this phenomenon from afar, and if these structures were indeed constructed with an efficiency approaching perfection, what would you see? You wouldn't notice a sudden drop in brightness. A gradual dimming might occur as light began to be siphoned away. But eventually, after generations or even millennia of continuous energy extraction, the star itself would effectively vanish from view. It would not explode. It would not collapse into a black hole. Instead, it would simply disappear, absorbed by its own artificial envelope. The space around it would darken, not because matter had been removed. The shell itself would remain. But because the starlight that normally illuminated that region was now contained within this immense structure, and if such structures were built on a large scale, across an entire region of space. Well, a truly vast area like the Boötes Void could appear exceptionally dark. Not simply because it's empty, galaxies are still present, though sparsely distributed. But because something is actively preventing light from escaping this region. It's as if countless stars have been systematically extinguished. Their radiant energy harnessed and contained within these colossal enclosures. Now, before you envision a galactic scale conspiracy of stellar hoarders, it's important to emphasize that this idea remains highly speculative. There is absolutely no direct evidence to support the existence of such megastructures in the Boötes. Void or anywhere else in the universe. It's more of a thought experiment. An attempt to explore the logical consequences of advanced technology and civilization reaching unimaginable levels. It's a what-if scenario. Born from a desire to grapple with both the vastness of space and the potential for life beyond Earth. Furthermore, there are significant practical challenges to constructing such massive structures. The sheer scale alone poses an insurmountable engineering hurdle. Requiring materials stronger and more abundant than anything we currently know. Then there's the problem of stability. Maintaining a perfectly spherical shell across light years would demand incredible precision and active control systems. And finally, there's the question of motivation. Why would a civilization undertake such a monumental project? Despite these challenges, the concept continues to fascinate scientists and science fiction writers alike. The notion that an advanced civilization could manipulate space and energy on this scale is both terrifying and inspiring. It highlights our own technological limitations and forces us to consider possibilities beyond our current scope of understanding. Even if the idea itself proves false, its exploration can teach us valuable lessons about physics. Engineering, and perhaps even the nature of intelligent life in the universe. Thinking about it a little more carefully, there's something inherently elegant to the thought of enclosed stars. You see, within our own solar system, planets exist as naturally occurring enclosures. The Earth itself surrounding our atmosphere. Containing all its weather systems within a breathable layer of gases and maintaining relatively constant surface temperature through complex physical processes. Stars are much larger. And require more sustained control for this type of enclosure to persist over long galactic time scales. But it's an interesting parallel nonetheless. Planets might be considered smaller scale enclosures in their own right. So, while the idea of a civilization actively concealing stars within vast structures remains firmly in the realm of speculation, a fascinating corner of astrophysics bordering on philosophical contemplation. It underscores the tantalizing possibility that our understanding of the universe is still profoundly incomplete. It reminds us that there may be things lurking just beyond the reach of our current instruments. Phenomena so strange and so advanced they defy easy categorization. And it's in these moments of intellectual humility, when we acknowledge the limits of our knowledge. That the true wonder of exploration begins. We continue to observe, to gather data, and to refine our theories. Perhaps one day, we'll uncover a piece of evidence that either confirms or refutes this intriguing possibility. Bringing us closer to understanding the enigmatic nature of the Boötes Void. Until then, it remains a profound mystery, a vast, dark canvas against which the stars appear as fleeting points of light. The second idea is far stranger. Perhaps the darkness is not natural at all. Imagine an ancient civilization, almost unimaginably old, expanding outward from a single point. Enclosing every star, it reaches inside vast shells to harvest its light. One by one, the stars would go dark from the outside in, until an entire region of the cosmos simply vanished from view. And so it's difficult to imagine a space so utterly devoid of matter that light itself struggles to find its way through. A region where galaxies are fewer than you might expect to see on a cloudless night sky. But harder still to grapple with is the potential explanation for this cosmic anomaly. Because what we know as the Boötes Void presents us with a truly extraordinary idea, a permanent wound. Perhaps etched into the very fabric of space itself. Consider, if you will, that moment just after the Big Bang. When everything in existence resided within an unimaginably small volume. In that instant, it is believed the universe didn't simply begin to expand. exploded outwards with a speed that defies comprehension. A period known as inflation, an event so rapid it stretched space itself. Inflating tiny quantum fluctuations into the colossal structures we observe today. Imagine blowing up a balloon, but instead of air filling its interior, you're expanding the very material of the balloon itself, creating new surface area seemingly from nothing. That initial inflationary epoch was not likely as perfectly smooth as our models suggest. The laws of physics governing that period are still imperfectly understood, and it's entirely possible, indeed, quite probable given the unpredictable nature of quantum events, that a flaw occurred within this process. A slight imbalance, an area where inflation stretched space just a little too far, too quickly. Think of it like pulling taffy. If you pull too vigorously in one spot, it can tear or thin out dramatically. In the vastness of the early universe, such a localized event would have had enormous consequences. It's theorized that this overinflation resulted not simply in an expansion, but rather in a catastrophic disruption. A tearing apart of what we know as the cosmic web. That intricate network of filaments and voids which defines the large-scale structure of the universe. The cosmic web, you see, is not merely empty space dispersed between galaxies. It's an enormous scaffolding, a framework built by gravity over billions of years. Where dark matter forms dense concentrations along these filaments, providing the gravitational glue that draws galaxies together. These connections are what shape our view of the cosmos. They dictate where galaxies cluster and where vast expanses of emptiness reside. If one region experienced a sudden, extreme extension during inflation, it would severely weaken or completely sever those filaments in place. Ripping apart what had begun to coalesce. Consequently, all the material that should have been drawn into that region by gravity the dark matter, the gas clouds, was instead flung outwards, dispersed across an enormous volume of space. It's as though a cosmic hand reached down and scooped out everything from that area. Leaving behind only the underlying fabric of space-time itself. What remains is precisely what we observe, a scar of nothingness. An immense void where the cosmic web simply doesn't exist. The structures, the galaxies and clusters of galaxies, which should have formed there are absent instead. You find relatively few small dwarf galaxies scattered sparsely across a region that ought to be teeming with life. Scientists remain uncertain about what exactly caused this catastrophic event, but various models attempt to explain. It within the parameters of known physics. Some posit that an unusual quantum field fluctuation, perhaps related to inflation itself, created a zone where the energy density was significantly lower than average, causing the localized overexpansion. Others suggest that a more exotic phenomenon, potentially linked to extra dimensions or alternative theories beyond our standard model of cosmology, might be at play. It's essential to note that these are theoretical explanations. direct observation of the very earliest moments of the universe is impossible. And so we must rely on indirect evidence and advanced modeling techniques to piece together the puzzle. The Boötes Void, however, provides a crucial observational constraint that compels us to refine our understanding of inflation and the fundamental physics that governs it. The absence of matter also tells its own story. In a universe governed by gravity, emptiness is itself an unusual state. Matter tends to clump together, forming galaxies, groups of galaxies. Eventually, large-scale structures like filaments and superclusters. The void defies this natural tendency. It's a region where gravity seemingly failed to take hold. A zone that has stubbornly resisted the gravitational pull of its surroundings for billions upon billions of years. Consider again that initial event, that hypothetical tier in space-time. It isn't merely an absence of stars and galaxies. But an absence of potential for those structures to form. The underlying conditions are such that gravity cannot effectively operate. Something fundamentally altered the physics of that locale. This could have far-reaching implications for our understanding of how matter distributes itself throughout the universe. The longevity of this void also suggests a truly permanent feature. Not simply a temporary gap that will eventually fill with matter. But an enduring consequence of conditions established in the very first moments after the Big Bang. It's not easily conceivable that anything could heal such a wound. That gravity and cosmic expansion would somehow restore what was lost. The scale is simply too immense, the disruption too profound. And it begs the question, are there other voids like this scattered across the cosmos? Are we witnessing just the most extreme example of a more common phenomenon? Telescopic surveys continue to map out ever larger portions of the universe. And as our observational capabilities improve, we will undoubtedly uncover further anomalies and unexpected structures that challenge our current cosmological models. Perhaps, if you look closely enough, one might discover other echoes of those initial inflationary events. Faint scars on the face of space-time, which tell a story far grander than we can currently comprehend. The sheer scale of the void also contributes to its unsettling nature. We often think of space as vast, but the Boötes Void takes that concept to an entirely new level. It stretches across hundreds of millions of light years. A distance so immense that it's difficult to grasp. To travel from one end to another, even at the speed of light, would take hundreds of millions of years, longer than the entire existence of humanity. The idea that such a significant volume of space could be essentially empty is truly remarkable. And challenging to our intuitive understanding of how the universe operates. It forces us to confront the possibility that the cosmos isn't as neatly organized or homogeneous as we might have previously assumed. But instead exhibits vast, unpredictable fluctuations in density and structure. The emptiness also lends a peculiar sense of isolation. A feeling of profound loneliness when considering its scale. It's hard not to feel humbled by this revelation, a reminder that our own galaxy, our own solar system, our very existence are, on the cosmic scale, incredibly tiny and isolated pockets within an ocean of otherwise barren space. The continued study of this void, the faint galaxies which inhabit it, the subtle fluctuations in its background radiation, represents a significant opportunity for deepening our insights into the early universe and developing a more fully textured and accurate view of how everything around us came to be. It is a place that will no doubt continue to challenge our assumptions. One whose mysteries invite continued exploration and reflection. The third idea is the loneliest of all. In the universe's first fraction of a second, as space itself unfurled, perhaps a flaw appeared. A place where the expansion ran too fast and tore the cosmic web apart. What we are drifting through in this telling is a scar, a permanent wound in the fabric of everything that has never healed. And so here we are, suspended within that immense absence. The scale of it continues to stretch your understanding, doesn't it? We've considered the possibilities, the rogue galaxy fleeing at impossible speeds. The bubble of warped space-time created by something unimaginably large. Even the fleeting suggestion of a collision with another universe. And each one offers a glimpse into the extraordinary physics that might have birthed this emptiness. But ultimately, perhaps we must accept that the precise origin of the Boötes Void remains elusive. It may well be a cosmic puzzle that resists complete resolution. A beautiful testament to the fact that even at the grandest scales, mysteries endure. It's almost comforting in its own way, isn't it? To realize there are questions the universe simply won't answer for us. There's a certain freedom in relinquishing the need to know everything. In surrendering to the acceptance of what remains unknown. And here within this void, that perspective feels particularly profound. This silence asks nothing of you. It doesn't demand explanation or recognition. It simply is. No swirling gases, no glittering stars, no bustling solar systems, just space, vast, unending space. You might find yourself imagining what it would be like to drift through here in a spacecraft. The only light filtering through portholes coming from your own ship's lamps. An infinite blackness surrounding you on every side. The radio silence unbroken by any signal from another world. It speaks not of danger, perhaps, but of something far more significant. Of utter and complete solitude. Not an unsettling loneliness, though rather a quiet communion with something truly immense, older than time itself. There's a deep calm that settles in when you contemplate the presence of something so ancient, something so still. The Boötes Void isn't actively doing anything. It's not expanding or contracting. It's not colliding or creating. It simply exists, a pocket of emptiness within an otherwise active and vibrant cosmos. And in that stillness, there is a peculiar sense of peace. You can feel the weight of eons resting on you. The slow turning of galaxies played out across billions of years. Yet here, in this place, all those grand motions seem to fade into insignificance. The universe's relentless activity recedes, and for a moment, everything softens. Consider how many dramas have unfolded in the observable universe since the Boötes Void began its existence. Stars born and died, planets coalesced and crumbled. Life emerged on some distant world and vanished without trace. All these events occurring within the swirling nebulae and energetic galaxies that surround this vast emptiness. But here, within the void itself, nothing has changed. There's been no grand narrative, no significant event, just an enduring state of quietude. It's easy to be drawn in by descriptions of violent cosmic phenomena. Supernova explosions ripping apart stars, or galactic collisions reshaping entire constellations. Those events are certainly captivating. And they serve as vital reminders of the dynamism inherent in the universe. But there's a different kind of beauty, a deeper resonance to be found in contemplating absence. In understanding that emptiness isn't simply nothing. It is a fundamental component of existence. Space itself, after all, is vast stretches of nothing at all. It's the canvas upon which everything else unfolds. And if you let go for just a moment, allowing yourself to truly feel the scale of this place, you can almost sense its patience. It has existed in this state for billions of years and will undoubtedly continue to do so for billions more. The universe has unfolded around it, within it, seemingly unaffected by its presence or absence. There's a humbling quality to that realization, a sensation that your own concerns, your daily worries and fleeting ambitions are insignificant compared to the vast timescales at play here. Perhaps that's why this emptiness can feel so deeply restful. It encourages a kind of release. The frantic energy of our lives, the constant striving for more or better, these things seem distant and unreal when faced with the immensity of this void. Let those thoughts drift away like stardust scattering on the cosmic wind. There's no need to grasp at meaning here. There's nothing to hold onto. Simply be. We have spent so much time searching for order and patterns in the universe. Trying to impose our human desire for predictability onto a cosmos that is fundamentally chaotic. But sometimes the most profound truths are revealed not through intricate calculations or complex theories, but through simple observation. By allowing ourselves to be still and quiet within the presence of something vast and unknown. And what better place to do that than here? Surrounded by this profound stillness, cradled in the arms of cosmic emptiness. You can almost feel the universe gently easing you into a state of tranquility. The questions, the anxieties, the incessant chatter of your mind, let them go. those thoughts to simply dissolve, like gas escaping from an airlock. There's no urgency here. No pressure to understand or to explain anything. Just peace. Imagine yourself floating freely within this void, weightless and unbound. The darkness surrounds you, but it is not oppressive. Rather, it feels protective. A gentle embrace that shelters you from the clamor of the world. You are suspended in a sea of quietude, cradled by an absence so profound it becomes almost tangible. It's easy to forget when we're caught up in the hustle and bustle of daily life. Just how small a part we play in this grand cosmic drama. Our planet, our solar system, our galaxy. They are all just tiny specks within the vast expanse of the universe. But that doesn't diminish your value. It simply puts things into perspective. The beauty of it lies in its silence, the deep, profound quiet that permeates every corner of this void is a balm to a restless mind. We live our lives surrounded by noise, the constant hum of technology. The incessant chatter of voices, the relentless demands of modern life. But here, there is nothing but stillness. And within that stillness, you can find a rare and precious sense of peace. There's no need to strive, no need to achieve, just be present and allow yourself to rest. You might be inclined to ask, what purpose does such an emptiness serve? Is it simply a cosmic anomaly, a random fluctuation in the fabric of space? Or is there a deeper reason for its existence? Something we haven't yet grasped or understood. These questions are valid, undoubtedly. They represent our innate human desire to find meaning and order. But perhaps here within the void, the most profound answers lie not in grand explanations, but in simple acceptance. Let go of those lingering inquiries. Allow them to drift away like distant galaxies receding into the cosmic haze. There is a quiet wisdom in accepting that some things simply are. Without need for justification or explanation. The Boötes Void exists, a vast and enduring absence within the fabric of reality. Offering us not answers, but an opportunity, a chance to rest, to let go. And to find solace in the simple beauty of nothingness. There is a deep stillness that settles over you as you surrender to this immense quietude. The boundaries between yourself and the cosmos seem to blur. You become one with the void. An integral part of its enduring peace. No longer constrained by the weight of your thoughts or the demands of your daily life. You drift effortlessly through this silent expanse. And now, as sleep begins to gently draw near, let it carry you deeper still. Downward into a quiet place within yourself. A sanctuary of stillness, mirroring the vast emptiness surrounding you. It is safe here, secure and tranquil, sheltered by the patient immensity of space. The universe will continue on its course long after you have closed your eyes. But in this moment, there is only peace, only rest. And so we turn at last toward the distant shore of light we left behind. The Boötes Void will go on as it always has, vast and patient and still. Holding its small handful of lonely galaxies in the dark. There is something strangely comforting in that emptiness, a reminder that even nothing has a shape. And that the silence between the stars is not empty of meaning. Rest now and let the quiet carry you. Thank you for spending this time among the stars with me. If you enjoyed the journey, a gentle like and a subscribe help more quiet dreamers find their way here. Until next time, rest well and keep wondering about the cosmos. Good night.